Today we're looking at graphing quadratic equations. In order to graph our quadratic equations, we're going to first go through and find our axis of symmetry. The axis of symmetry is the line that actually divides our parabola in half. If I have a parabola, my axis of symmetry goes right down the middle and divides it in half. After we find our axis of symmetry, we want to go through and find our x value, our x-intercepts, and our y-intercepts. Our y-intercept is actually always going to be 0 and then whatever our c is. It's always good, if possible, to put our equations into standard form, ax squared plus bx plus c, before we get started. So looking at example 1. In example 1, let's go through and find my axis of symmetry. My axis of symmetry is going to be the opposite of b. X is equal to the opposite of b over 2a. Remember, this is my a, my b, and my c. So my axis of symmetry is going to be x is equal to the opposite of 2 over 2 times 1. So that's going to be negative 2 over 2, which is negative 1. So my axis of symmetry is x equals negative 1. So going over here to my graph, I'm going to go to negative 1. And put a nice little dash line, vertical dash line going straight up and down. To find my vertex, I'm going to go plug this negative 1 back into the equation. So I'm going to have y equals, I'm going to go back and put in empty parentheses everywhere I need to substitute for my x. And that should be a minus there, minus 8. So I'm going to go back and plug in a negative 1 into each of these spots. So I now have 1 minus 2 minus 8, which then gives me a negative 9. So my vertex is located at negative 1 and negative 9. So I go down here to negative 1. I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and put a point. My y-intercept is the next point that's the easiest to get, because it is always 0, comma c. Well, c in this case is negative 8, so my y-intercept is at 0, comma negative 8. So my y-intercept is right here. And the nice thing about parabolas is there's actually one just like it on the opposite side of the axis of symmetry. So my parabola is going up like this. So technically we've already graphed it. Here we're asking for the x-intercepts as well. There are a couple of different ways to do the x-intercepts. We can take and say 0 is equal to x squared plus 2x minus 8 and go through and solve, or we can use our graphing calculator. We're going to be using our graphing calculator, so I go into my graphing calculator, and when we turn it on, it should look like this at our home screen. So I take and I hit the y equals about, and here in y1 I want to place my equation. Here I'm going to put in x squared plus 2x minus 8. Then I'm going to place in here in y2, I'm going to put in 0, because I'm looking for my x-intercept, which therefore y would equal 0. So I can find the intersection of these two. If I hit graph, here is the graph of my parabola. I want to now go and find my x-intercepts, these points here and here. To do that, I'm going to hit the second button and trace, which are right above it. It says calc. So calculating, I want to calculate my intercept, which is 5. My first curve, enter. My second curve is here. Then I'm going to move my cursor over here. Say, oh, it's about right here. Just got to get close to it and hit enter, because I'm just guessing about where it is. And it tells me that it's exactly located at negative 4, 0. And there's one of my x-intercepts. And I'm going to move my cursor over here in this general area. And I'm going to do second and calculate again my intersect. First curve, and then my second curve. And I'm going to guess, oh, somewhere over here. Get close. Doesn't have to be exact, just close to where it is. And it tells me that this one is located at 2, 0. So if I go in here to my graph, and I put my points -4, so 1, 2, 3, 4, 0, and then at 2, 0, I know that my parabola goes up through here, just like so. And we have just graphed our quadratic equation. Looking at example 2. In example 2, I first want to find my axis of symmetry. Remember, the axis of symmetry is x is equal to the opposite of b over 2a. So with this right here, it's always a good idea to go find my ABCs. Finding the ABCs, remember, is always as easy as 1, 2, 3. So A is -4. B in this case is 0, because there is no x term. And C is 9. So my axis of symmetry is going to be x is equal to the opposite of 0 over 2 times -4. And it doesn't matter what's on the bottom, this still comes out to be 0. The axis of symmetry is x equals 0, or my y-axis. So I'm going to go through and place a dashed line right there. Since it's on the y-axis, our vertex and our y-intercept will be the same. In this case, it is going to be 0, 9, and this one will also be 0, 9. So I go in here, at 0, 9, place a point. I need to find my x-intercepts. Well, this one's going to be going down. Since it's going down, there should not be any x-intercepts. Now, if we go back to our graphing utility here, my y equals, I'm going to clear this one out, and I'm going to put in -4 x squared plus 9, and I hit graph. There it is. Oh, wait a minute. It wasn't -9, it was +9. So I put my point in the wrong spot to start with. So it's not down here. It's actually going to be way up here. So there will be an x-intercept. To find my x-intercepts, it is going down. I'm going to go in here and do second. Whoop, back to my y. I have y2 is equal to 0. So now I'm going to go calculate first curve, second curve, come over here to where it's located, hit enter. It's at -1.5 and 0. To find the other one, I get my calculator back, and I say calculate first curve, second curve. I come over here and guess, oh, it's somewhere about in here. Enter. It's at a positive 1.50. So when I go to graph this one, I have -1.5, which is right here, +1.5, which is right here, and it's going down. There we have graphed our parabolas. To graph these, always look for your axis of symmetry first, your vertex, your y-intercept, x-intercepts if they are available. Good luck with your graphing.